All right, y'all, this is number 14 out of 7.4, and it says to verify that the following equation is an identity. So it says to verify the identity, start with a more complicated side and transform it to look like the other side. Choose the correct transformation and transform the expression at each step. Okay, so look, y'all, first thing I'm going to do here, I'm going to write this as 5 sine of x plus 5 cosine of x. I'm going to write it twice because that is exactly what it means to do to square something, right? We're just going to write it twice. Okay, so look, y'all, we're going to go like this. 5 times 5, 25. Sine times sine, sine squared x. 5 times 5, 25. Sine x times cosine x, it's just sine x cosine x, okay? So y'all, I've already used that guy. I don't want to use him anymore. So 5 times 5, again, 25. Cosine times sine, I'm going to write it actually, guys, as sine x cosine x, okay? Because when I'm multiplying cosine or sine, whichever one prefers, doesn't really matter, okay? And then 5 times 5, again, 25. Cosine times cosine, cosine squared x. Okay, so y'all, I'm going to write on the next page. So we have a 25 sine squared x, we have a 25 cosine squared x, and 2 of those is going to give me 50. So let's write like this: 25 sine squared x plus 25 cosine squared x plus 50 sine x cosine x, okay? Y'all, from here, we can factor out a 25. It's going to give me sine squared plus cosine squared x plus 50 sine x cosine x, okay? And y'all, we know that from our Pythagorean identity, that's going to be equal to 1. We still got a 50 sine x cosine x. And then finally, this should just be 25 plus 50 sine of x cosine of x. And y'all, if I scroll back, let's see, what do we got here? We got a 25 sine of 2x. Okay, so let's see. Y'all, we got some double angle identities. Let me see if I can get that real quick going. Okay, so I'm going to come back here. Those are half angle identities. I think we got double angle identities maybe here. If they're not, here we go. So y'all, I'm going to take a screenshot of that. Okay, I'm going to come back this way. Okay, and I'm going to upload this right here because, let's see, 2 sine of a cosine of a is a sine of 2a. So look, y'all, if I think about this, 25 plus 2 times 25 sine x cosine x, okay? And I look at this, let's see, what do we got here? Let's see. 2 sine a cosine a. There we go, y'all. Look, these are my a's, right? Let's see. And actually, you know what? Why don't we rewrite it this way? Why don't we put our 25 first and our 2 right here? Because now we can say this is going to be 25. This right here, y'all, should be sine of 2 times a sine. Sorry, let me come back one more time. There we go. That's going to be sine of 2x, right? So 25 sine 2x, which is exactly what we got there, right? So let's come back here to our problem. Okay. And let me see if we can start filling in some blanks. So y'all, I had a 25 sine squared x. Oops, not a 2, sorry. There we go. X. Okay, plus 50 sine x cosine x plus 25 cosine squared x. Okay, check that. Okay, we expanded, right? Boom. Okay, let's see. What's the next action asking me to do? Why don't we apply a Pythagorean identity? Because we know this is going to be 25 because of the sine squared plus cosine squared, okay, plus, and then I believe we had a 50 sine x cosine x, okay, all right. Okay, so here, guys, we are applying the double angle identity, right, for the sine of 2x, and we got it. So that was number 14, y'all, out of 7.4.